Hello everyone and welcome back to my YouTube channel. My name is Ahrish Shah, branch CSC live number 23CY1517, section Galpin. The subject today is Principles of Programming and the topic is History of Computers. A brief history of computers. Computers have revolutionized the way we live, work and communicate, from the early mechanical calculators to the powerful interconnected devices of today. The history of computers is a remarkable journey of technological innovation. Early computing devices. Abacus. Abacus was invented by the Chinese around 4000 years ago. It's a wooden rack with metal rods with beads attached to them. The abacus operator moves the beads according to certain guidelines to complete arithmetic computations. Naper's bone. John Naper devised Naper's bone, a manually operated calculating apparatus for calculating. This instrument used 9 separate ivory strips marked with numerals to multiply and divide. It was also the first machine to calculate using the decimal point system. Pascaline. Pascaline was invented in 1942 by Blaise Pascal, a French mathematician and philosopher. It is thought to be the first mechanical and automated calculator. It was a wooden box with gears and wheels inside. Stepped reckoner or Lewis wheels. In 1973, a German mathematician philosopher named Gottfried Wilhelm Leibniz improved on Pascal's invention to create this apparatus. It was a digital mechanical calculator known as the stepped reckoner because it used fluted drums instead of gears. Difference engine. In the early 1820s, Charles Babbage created the difference engine. It was a mechanical computer that could do the basic computations. It was a steam-powered calculating machine used to solve numerical tables such as logarithm tables. Analytical engine. Charles Babbage created another calculating machine, the analytical engine, in 1830. It is a mechanical computer that took input from punch cards. It was capable of solving any mathematical problem and storing data in an indefinite memory. Tabulating machine. An American statistician, Herman Hollerith, invented this machine in the year 1890. Tabulating machine was a punch card based mechanical tabulator. It could compute statistics and record or sort data or information. Hollerith began manufacturing these machines in his company, which ultimately became International Business Machines (IBM) in 1924. Differential analyzer. Werner Bush introduced the first electrical computer, the differential analyzer, in 1930. This machine is made up of vacuum tubes that switch electrical impulses in order to do calculations. It was capable of performing 25 calculations in a matter of minutes. Mark I. Howard Aiken planned to build a machine in 1937 that could conduct massive calculations or calculations using enormous numbers. The Mark I computer was constructed in 1944 as a collaboration between IBM and Howard. History of computers. The word computer has a very interesting origin. It was first used in the 16th century for a person who used to compute, i.e., do calculations. The word was used in the same sense as a noun until the 20th century. Women were hired as human computers to carry out all forms of calculations and computations. By the last part of the 19th century, the word was used to describe machines that did calculations. The modern day use of the word is generally describe programmable digital devices that run on electricity. Since the evolution of humans, devices have been used for calculations for thousands of years. One of the earliest and most known devices was an abacus. Then in 1822, the father of computers, Charles Babbage, began developing what would be the first mechanical computer, and then in 1833 he actually designed an analytical engine which was a general purpose computer. It contained an ALU, some basic flowchart principles, and the concept of integrated memory. Then more than a century later, in the history of computers, we got a first electronic computer for general purpose. It was the ENIAC, which stands for Electronic Numerical Integrator and Computer. The inventors of this computer were John W. McElhenney and J. Presper Exert. And with times, the technology developed and the computers got smaller and the processing got faster. We got our first laptop in 1981 and it was introduced by Adam Osborne and Epson. Generations of computers. First generation, 1940s to 1950s. Vacuum, tube-based computers like the ENIAC emerged. They were massive, consumed more power, and required manual programming. Second generation, 1950 to 1960s. Transistors replaced vacuum tubes, making computers smaller and more reliable. COBOL and Fortran were popular programming languages. Third generation, 1960s to 1970s. Integrated circuits allowed further miniaturization. IBM System and 360 exemplified this era. Fourth generation, 1970s to 1980s. Microprocessors and personal computers (PCs) arrived. Apple II and IBM PC were game changers. Fifth generation, 1980s to present. Advances in artificial intelligence, parallel processing, and supercomputers characterized this era. The birth of the modern computer. The foundations of the modern computer were laid in the 1930s and 1940s. Pioneering work by visionaries like Alan Turing and Charles Babbage led to the development of early digital computers, paving the way for the computing revolution to come. Breakthroughs in programming, logic, and hardware designed during this era laid the groundwork for the programmable general-purpose computers we use today. The birth of the modern computer ushered in a new era of technological advancement and innovation. The rise of personal computers, the advent of PCs. The 1970s and 1980s saw the introduction of affordable personal computers such as the Apple II and IBM PC, which brought computing power into homes and small businesses. Increased accessibility. As personal computers became more user friendly and widespread, they empowered individuals to perform a variety of tasks from word processing to programming right from their own desk. Democratization of technology. The rise of personal computers democratized access to technology, allowing people from all walks of life to benefit from the computation revolution and unleash their creativity. Internet and the digital age. The birth of the Internet. The development of the ARPANET in the 1960s, which later evolved into the modern Internet, the World Wide Web. The creation of the World Wide Web by Tim Berners-Lee in the early 1990s and enabling the sharing of information globally. The digital revolution. The widespread adoption of digital technologies, including personal computers, smartphones, and social media platforms. The internet and the digital age have transformed the way we live, work, and communicate. The birth of the internet and the World Wide Web have enabled the global sharing of information and the rise of digital technologies, ushering in a new era of connectivity and innovation. Types of computer. Analog computers. Analog computers are built with various components such as gears and levers. With no electrical components, one advantage of analog computation is that designing and building an analog computer to tackle a specific problem can be quite straightforward. Digital computers. Information in a digital computer is represented in discrete form, typically as sequences of zeros and ones, binary digit or bits. A digital computer is a system or gadget that can process any type of information in a matter of seconds. Digital computers are categorized into many different types. They are as follows. Mainframe computers. It is a computer that is generally utilized by large enterprises for mission critical activities such as massive data processing. Mainframe computers were distinguished by massive storage capacities, quick components, and powerful computational capabilities. Because they were complicated systems, they were managed by a team of system programmers who had sole access to the computer. These machines are now referred to as servers rather than mainframes. Supercomputers. The most powerful computers to date are commonly referred to as supercomputers. Supercomputers are enormous systems that are purpose built to solve complicated scientific and industrial problems. Quantum mechanics, weather forecasting, oil and gas exploration, molecular modeling, physical simulations, aerodynamics, nuclear fusion research, and crypto analysis are all done on supercomputers. Mini computers. A mini computer is a type of computer that has many of the same features and capabilities as a larger computer, but is smaller in size. Mini computers, which are relatively small and affordable, were often employed in a single department of an organization and were often dedicated to a specific task or shared by a small group. Microcomputers. A microcomputer is a small computer that is based on a microprocessor integrated circuit, often known as a chip. A microcomputer is a system that incorporates at a minimum a microprocessor, program memory, data memory, and input-output system. A microcomputer is now commonly referred to as a personal computer. These embedded processor. These are miniature computers that control electrical and mechanical processes with basic microprocessors. Embedded processors are often simple in design, have limited processing capabilities and I/O capabilities, and need little power. Ordinary microprocessors and microcontrollers are the two primary types of embedded processors. Embedded processors are employed in systems that do not require the computing capability of traditional devices such as desktop computers, laptop computers, or workstations. Advancement in computer hardware. Over the decades, computer hardware has undergone remarkable advancements, enabling faster, more powerful, and energy efficient computing. Innovations in microprocessors, memory, storage, and other components have driven the continuous evolution of computer systems. Increased transistor density and advancements in materials and manufacturing processes have allowed for the creation of increasingly compact and capable hardware, powering the growth of mobile devices and embedded systems. Developments in computer software. Evolution of programming languages from early assembly languages to high-level object-oriented languages that enable more complex software development. Advancement in operating systems. Improving user interface security features and resource management for better system performance and reliability. Rise of open source software. Collaborative development of software by global communities leading to innovative and cost-effective solutions. The impact of computers on society. Revolutionizing communication. Computers have transformed how we communicate, enabling instant global connectivity and the rapid exchange of information. Transforming workplaces. Computers have increased productivity, streamlined operations, and enabled new modes of collaboration in workplaces around the world. Enhancing education. Digital learning tools and online resources have made education more accessible and engaging, opening new avenues for knowledge acquisition. Shaping entertainment. Computers have revolutionized the entertainment industry from immersive gaming experiences to streaming platforms that deliver content on demand. The future of computers. As technology continues to advance, the future of computers holds immense promise. Except foresee the rise of quantum computing, artificial intelligence, and seamless human-computer interaction, revolutionizing how we process data and tackle complex programs. Quantum computers with the ability to harness the principle of quantum mechanics will vastly increase computing power and enable breakthroughs in fields like cryptography and material science. Quantum computing is poised to redefine the boundaries of what's possible. Advancements in AI and machine learning will make computers more intelligent, adaptive, and capable of tackling tasks previously thought to be the domain of humans. From autonomous vehicles to personalized healthcare, the future of computers will be defined by the ability to learn, reason, and make intelligent decisions. The seamless integration of computers with our daily lives through wearable devices, voice assistants, and augmented reality will create a more immersive and intuitive computing experience. The line between digital and the physical world will continue to blur, transforming how we interact with information and each other. Thank you, and I hope you like this video.